Day 153 of doing a LeetCode problem every day until I get a job. All right, y'all. Welcome back. Welcome back. We're at day 153 and we're still going strong. Hope y'all are still motivated. Hope y'all are still disciplined. And I hope y'all are staying consistent because that's what it takes to get to the end of this LeetCode journey, y'all. It's going to take a long time and it's going to take a lot of discipline. It's going to take a lot of practice, y'all. So just keep going. Keep pushing through. Don't let anybody tell you can't do it. Don't let anybody tell you, oh, it's too hard. Oh, you can't do that. You're not smart enough. No, you could do whatever you put your mind to, especially if you decide that you're going to put the work in, y'all. If you put your mind to something and put the work in, you can't fail. Just keep going and don't give up. Keep trying and keep trying until you get it, y'all. It gets frustrating. I know it frustrates us all. So just know you're not in it alone. We're all trying to accomplish this goal together. And yeah, y'all just keep going. Don't give up. Now, before we get started today, don't forget, bring a mouse right over here and click that subscribe button for me, y'all. Then after you click that subscribe button, go ahead and smash that like button for me, y'all. Then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we could run up this engagement and we could push this content out to a broader audience, y'all. As Swift community members, it's up to us to help the community grow. And in order to do that, we need to share this Swift content with as many people as we can find that will watch it and that's interested in Swift. And our support is appreciated for that, y'all. So let's see what question we have here today. And today we have question number 160, intersection of 2 linked lists. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well because we're all here trying to learn something. And if you don't understand the question, you probably won't learn anything, y'all. We're just getting started. We're about 2 days in of we're doing a month of easy hash table problems before we get started on the LeetCode 150 interview problems. So we're just getting started with that one. On day 2, we got about 28, 29 more days of that, and then we're going to keep going. We're going to do some get into some medium and harder problems, y'all. But right now we're doing a month of easy hash tables. So let's see what the question says. It says, given the heads of 2 singly linked lists, head A and head B, return the node at which the 2 lists intersect. If the 2 linked lists have no intersection at all, return null. For example, the following 2 linked lists begin to intersect at C1. So you see right here we have A1, A2, B1, B2, B3, they both intersect right here at C1. So it says, the test cases are generated such that there are no cycles anywhere in the entire linked list. So yesterday we went over cycles and there are no cycles in this list. If you don't know what a cycle is, I suggest you check out yesterday's video, day 152, I believe. The cycle list, the cycle will be in the name. It will be something cycle list in the name. Then it says, note that the linked list must retain their original structure after the function returns. So let's see what it says. We had the custom judge. It says the inputs to judge are given as follows. Your program is not given these inputs. So it says intersect val, the value of the node where the intersection occurs. This is 0 if there's no intersection node. List A, the first linked list. List B, the second linked list. Skip A, the number of nodes to skip in list A starting from the head to get to the intersected node. Skip B, the number of nodes to skip ahead in list B starting from the head to get to the intersected node. The judge will then create the link structure based on these inputs and pass the 2 heads, head A and head B, to your program. If you correctly return the intersected node, then your solution will be accepted. So let's look at it. I don't know what to think about this problem, y'all, because it literally tells us right here, intersect value 8. The output is intersected at 8. You know what I'm saying? So it got to be something more to this problem because it does the same thing down here. It says intersect val 2. The output is intersected at 2. So I don't know why you can't just return okay, because it says right here the value of the node where it says right here the inputs to the judge are given as follows, but this is what we're worried about. Your program is not given these inputs. So I guess we can't just return intersected value because it's not given to us as a parameter or anything like that. So, but yeah, it basically tells us intersect value is 8. We want to return the intersect value, so it's 8. But we have to remember our program is not given any of this, so it's up to us to figure this stuff out, I guess. But all right, so let's look at it. Let's go through this example 1. So we have example 1. We have the input intersect value 8. So just so we clear, this stuff is coming from right here, which our program is not giving these inputs. But so let's go through them. It says input intersect value equals 8. List A equals an array of integers 4, 1, or a list of nodes 4, 1, 8, 4, 5. List B is an array of integers or list of nodes 5, 6, 1, 8, 4, 5. Skip A equals 2. That's because we could skip these two to get to the intersected value, which is 8. And skip B equals 3. That's because we can skip these 3 to get to the intersected value, which is 8. And then the output is intersected at 8. So let's look at the explanation. It says the intersected node's value is 8. Note that this must not be 0 if the two lists intersect. From the head of A, it reads 4, 1, 8, 4, 5. From the head of B, it reads 5, 6, 1, 8, 4, 5. There are two nodes before the intersected node in A, right? So that's these, boom. Then there are 3 nodes before the intersected node in B, boom, that's these 3. Then it says, note that the intersected node's value is not 1 because the node with value 1 in A, the nodes with value 1 in A and B, second node in A, third node in B. So this is second node in A, third node in B would be 1, right? Are two different node references. In other words, they point to two different locations in memory, while the nodes with value 8 in A and B, third node in third node in A, boom, and the fourth node in B, boom, right here, point to the same location in memory, right? So these ones point to different locations in memory, but this 8 points to the same reference or location in memory, right? So for list A and list B, this 8 points to the same location in memory, whereas these two ones point in different locations, because you'll notice they both have 1s and they both have 8s. The difference is these 1s point to different locations in memory, whereas these 8s point to the same location as memory, as you can see in this picture above. So like I said before, we just want to return the intersected node, even because these are not given to us in our program. So we have to figure that out on our own through our coding, right? It says your program is not given these inputs. That is key. So now let's look at example 2. Example 2, we have the intersect value 2. That's this 2 right here. Boom. Then we have list A, an array of integers or list nodes, or an array of nodes, or a list of nodes 1, 9, 1, 2, 4. Then we have list B and list B is another array of integers or list nodes 3, 2, 4. Then we skip A 3. That's because skip A equals 3. That's because we could skip these 3 to get to the intersected value, which is 2, and skip B equals 1 because we could just skip this one node and to get to the intersected value, which is 2, right? We go skip 3 to get to this intersecting node, which is 2, and here we could skip 1 to get to the intersecting node, which is 2. The output intersected at 2. We already knew that because the intersection value is 2, which is, like I said, I don't get that, but hey. The explanation says the intersecting node's value is 2. Note that this must not be 0 if the two lists intersect. From the head of A, it reads 1, 9, 1, 2, 4. From the head of B, it reads 3, 2, 4. There are 3 nodes before the intersecting node in A, and there are 1 node before the intersecting node in B, right? So, end of the day, output is 2 because we intersect at 2, right? On both nodes. Like we said before, this is where list A and list B come to share the same location in memory, starts at 2. So let's look at example 3 where there are no intersections. Just in case, we have the input intersection intersect val equals 0. List A equals an array of integers or list nodes 264. List B equals another array of integers or list nodes 1 and 5. Skip A equals 3 because we could skip all of them because the intersect val is 0. Skip B equals 2 because we could skip all of them because the intersect val is, it doesn't intersect, period. And the output says no intersection. The explanation from the head of A, it reads 264. From the head of B, it reads 15. Since the two lists do not intersect val must be 0, while skip A and skip B can be arbitrary values. Explanation, the two lists do not intersect, so we return null. Okay, y'all, so what we doing is we just want to find where list A and list B intersect and begin to share the same location or point to the same location in memory, right? So in order to do that, it's not that difficult, y'all. The code's not even that long. First thing we're just going to do, we're going to say guard head A, excuse me, make that capital A, guard head A, excuse me, does not equal nil, so exclamation point equals nil, comma, head B does not equal nil, else return nil. So if there are no values in these, in head A or head B, we're just going to return nil, like if it's a blank array or something. Then we're going to declare a variable called A. That's going to be a list node, question mark, set that equal to head A. We're going to initialize that with head A. Then we're going to do the same thing for B. We're going to say declare a variable called B, colon, list node, question mark, equals head B, right? Then we're going to come down here and we're going to say while A does not, exclamation point, equals two equal sign, B, So what this is really saying is while A does not, while they are not sharing the same, where is that? While they're not sharing, what's it called? Or pointing to the same, while they're not pointing to the same location, right? So here you go. They point to two different locations in this example, right? But so this is saying while A and B point to two different locations, that's basically what this is saying with the three equal signs. With the two equal signs and the exclamation point, right? So that's like a more explicit way to check a value or compare values, I should say. Then we're going to come down here and we are going to say A equals nil. So if A equals nil, what we're going to do is, let's see, if it does equal nil, then we're going to say head B. If it doesn't equal nil, we're going to say A. We're just going to move on to the next. We're going to say A question mark dot next. Then we're going to do the same thing down here. We're going to say B equals B is equal to nil. So what this is going to do, what this two equal signs do, is it's just checking to see if it's true. We're checking to see if A equals A. We're checking to see if A equals A. If that's true, or we're checking to see if A equals nil or it doesn't equal nil, right? So if it does equal nil, then we're going to return head B. If it doesn't equal nil, then we're going to go to return A dot next, right? And we're going to do the same thing for B. So if B equals B and that does not, if B equals B is not equal to nil or is equal to nil, because remember, this is a Boolean right here. This is going to return true or false. So if B equals B is true, then we're going to come over here and we're going to return head A. But if B equals B is equal to nil, then what we're going to do, or is false, or B equals B is equal to nil, if that's false, then we're going to say B, or we're going to return, we're going to say B dot, or B question mark dot next, y'all. And then we're going to come down here and we are going to say return A. So let's run it. See how it runs, y'all. Okay. So let's see what happens. Let's see what we did wrong here. Oh, typo. Excuse me, y'all. Typo. All right, now let's run it. There it is, y'all. There it is. So let's submit it. Make sure it's still submitted. Make sure it still works. Still runs like how it's supposed to. Boom. 107 millisecond speeds. 52.50% of users with Swift, y'all. Not too bad. Not too bad at all. And the solution, I feel like this is an easy to understand solution for real, y'all. So check it out. Get one more look at the code. And I hope to see y'all tomorrow for another day, another LeetCode problem. Peace.